If you're into portable ham radio or like to do parks in the air, then most likely you've heard of Greg KJ6ER's POTA Performer. And a lot of you might be using it. But what most people don't know is he actually has a few other antenna designs that might have advantages over the Performer. Today I want to focus on his Challenger antenna, which is an off-center fed vertical half wave. I've been using this antenna quite a bit lately and I've been very impressed with its performance. I'll talk about the advantages of this antenna, what you're going to need to build it, what components you might need to buy. I'll show you how to set it up and tune it in the field. I'll do a couple comparisons against the Performer, and then finally I'll do a Parks on the Air activation and share those results with you. Let me talk briefly about the advantages of the Challenger over the Performer. First of all, it has a slight advantage in efficiency. The Challenger is 92 to 94% efficient depending on what components you choose. The Performer is 90% efficient, which is still very good, but the Challenger has a slight advantage. The Challenger also has a lower takeoff angle, 21 degrees over the Performer's 24 degrees. So if you're looking for DX, this might be a better antenna. A quarter wave vertical like the Performer requires a very good ground plane. Half wave antennas and off-center fed half wave antennas only need a small counterpoise. So the footprint of this antenna is much smaller. You know, on 20 meters, the Performer, if you're putting the radials at 180 degrees, that's 33 feet that you're taking up. If you're in a small park or a busy park, this is not a great antenna. So having a smaller footprint makes this antenna quicker and easier to set up. The other advantage of this antenna is it's very broad band, meaning it has a great SWR from one end of the band to the other end of the band without any adjustments. So if you like to operate different modes, single sideband, digital, and CW, this is a great antenna. You can tune the antenna for 20 meters and work at the very top single sideband and move down to the digital and CW portion of the bands and still have a great SWR. Let me talk a little bit about the differences between a quarter wave antenna and a half wave antenna. First of all, quarter wave antennas are very popular for portable operations. You can take something like a 17-foot whip, adjust the length, and have a resonant antenna from 20 meters all the way to 6 meters. You also don't need any sort of matching unit. The impedance is close to 50 ohms. The downside to a quarter wave vertical is you need a really good ground plane. Otherwise, you're going to have very high losses. In fact, without a good ground plane, you can have up to 50% ground loss. That's why the Performer works so well. Raising the radials off the ground decreases these losses, and you have a very efficient antenna. So at the feed point of a quarter wave, the current is at its maximum and the voltage is at its minimum. And that current needs a place to flow, and that's why it needs such a good ground plane, because the radiating element is only half of the antenna. The ground plane is the other half. So let me talk about half wave antennas. As you move the feed point to something like an end-fed half wave, now you have current at a minimum and voltage at a maximum. So if you plug that into Ohm's law, voltage over current equals impedance, now you're going to have a very high impedance. And this requires a matching unit, something like a 49 to 1, 56 to 1, or 64 to 1 unun, to bring that impedance that can be a couple thousand ohms down to 50 ohms that matches your coax. The problem with these ununs is they typically have a lot of loss. A typical 49 to 1 unun can have up to 20% losses. There are end-fed half-wave ununs that are more efficient, but they're often more expensive and they use a very thick toroid, something like the My Antennas 56 to 1, which is what Greg recommends for his Dominator antenna. This has a 91% efficiency, but I think it costs something like $90. With the current being the minimum at the feed point of a half wave, you don't really need an extensive radial system. A short counterpoise, often around 5% of a wavelength, is all you need. Some people say you don't need a counterpoise with a half wave antenna. At this point, your coax shield or your radio is acting as the counterpoise. So a short counterpoise is recommended to keep common mode current off the feed line for the small amount of return current on a half-wave antenna. With the Challenger antenna, Greg moved the feed point slightly from the in-fed half-wave. And what this does is it lowers the impedance at the feed point. So you can now use a 4-to-1 unun to match around a 200 ohm impedance. And the advantage of a 4-to-1 unun is they're fairly cheap and they're really efficient. Depending on which one you choose, it's around 92 to 94% efficiency. In fact, the Challenger is Greg's most efficient antenna design. All right, so let's go over a few of the ways to build this antenna. First of all, you're going to need a way to raise the antenna off the ground a little bit. I've got a tripod here. In fact, this is a tripod I use for the POTA Performer. If you got one of those, you can use the same tripod. Or you can make like something like a PVC mount, really anything that raises it about 2 to 3 feet off the ground. I find that much more than that, you don't get as good as SWR reading. It doesn't look as good on the analyzer. So I found about 2 to 3 feet is probably ideal for the Challenger. As far as the radiating element, to get on 20 meters, you're going to need a 25-foot whip, or you can make a wire version of this antenna that you can easily support with a mast or throw it up in a tree. That's going to be your cheaper option. The 25-foot whips are kind of expensive. They're around $100 for the Chameleon. They're very high quality whips. But the other thing with these whips is they can catch a lot of wind. So if you live in a windy area like I do, you need to have a secure mount. So this actually tripod doesn't work very well for the Challenger. I often use the PVC mount with guy lines, and that works much better when it's real windy. So you're going to need a way to either connect your wire or your whip to the 4-to-1 unit. And so what I did here is I just have bullet connections that go in the SO239. I believe this is a 4mm bullet connection that fits in there pretty well. And that goes in the center connector and just goes down to the 4-to-1. Greg basically uses a 3/8 by 24 bolt and just puts it through a mirror mount to a coupling nut, and a wire's connected to that going to the 4-to-1. Either way, you just got to connect the radiating element to the 4-to-1. As far as 4-to-1 ununs, you have a couple choices. Greg has 2 options. The LDG is a cheaper option. Around for about $30, you can get this LDG 4-to-1 unun. Make sure you get an unun, not the ballon. The unun is green. And for about $30, this is 92% efficient. If you want to spend a little bit more money and get a slight advantage of efficiency, the Palomar Engineering makes a 4-to-1 unun that's 94% efficient. This right here is actually the 500 watt version. I'm a CW operator, and even though I don't run 100 watts very often, I want the opportunity to do that. And on the Palomar Engineering website, on the 100 watt version of the 4-to-1, they recommend making sure the 4-to-1 is not heating up at 100 watts. And then if it is, you need to decrease your power. So I wanted one that I could run 100 watts all day with and not have any problems. So I got the 500 watt version. And then this is a choke. You're going to need a choke below the 4-to-1. This is just a cheap choke that I built. You can order them for Palomar Engineering. Greg has 2 options. I think the cheaper one from Palomar Engineering is around $30. And then this one here, I think it's $70. This one has slightly lower loss, but there's not much difference between the cheap version and the more expensive version. And then of course you're going to need your linked counterpoise. And Greg has dimensions on what links to cut this on his document. I'll try to link it in the description. And so what I have here is a lot of these 4-to-1s don't have a way to connect the counterpoise. The LDG, you can just connect it right here. On these, you just connect it to the SO239. On the 500 watt version, it's sealed, so I connected it to the SO239 on the choke. And then I just have a quick bullet connector here as well that I can take off. And then on the counterpoise, you'll see that I've got these spade connections, so I can quickly change bands. I can just unplug one and change bands. All right, so let me set up this antenna and show you how I deploy it in the field. All right, I'm going to show you how to deploy this antenna and show you how quick and easy this can be. I use a little ground spike. Actually, there's a giant ground spike. I 3D printed some little adapters that kind of are a tight fit for that 2-inch PVC pipe. So I'm going to go ahead and get this in the ground here. Hopefully, ground here is pretty hard. And you may not need a spike. In fact, if it's not windy, some people only use a spike. So I'm going to slide this on top here. And that prevents it. It would probably be okay, but it's fairly windy today, so I'm going to go ahead and set up the guys as well. I usually don't get this thing super straight, but it's good enough. Let's see here. Let's shorten this a little bit. Got a cactus. All right, here's the third one here. All right, so that's pretty much it. I've got the counterpoise just laid on the ground here. And I'm going to go ahead and hook up the coax, and we'll hook it up to analyzer. Now, if you use an antenna quite a bit, you kind of know where to put the whip for your desired band. And I'm pretty sure if I extend this antenna and leave one section down, it'll be pretty close on 20 meters. All right, it should be something like right there. Now, this antenna is already blown over, but I think this is going to keep it pretty secure. I don't know if you can see how much that antenna is blowing over, but I think we'll be okay. All right, so I've got the antenna hooked up to the Nano VNA, and I'm using the Nano VNA Saver. I usually don't use this out in the field, but I wanted to share some screenshots with you that hopefully will kind of show you how good the SWR curve looks on this antenna. All right, so I just ran a sweep on 20 meters. You can see the lowest point's kind of in the middle band. I'm a CW operator, so I might just lengthen the antenna and move that SWR dip over just a little bit. All right, so I'm gonna sweep it again. So yeah, that looks pretty good. I mean, there's not much difference here. So let's move this to right here. I'm gonna put a marker at the very top of the band and then a marker at the very bottom. And so at 14.0175, we have a SWR 1:1. Or excuse me, 1.1 to 1. And at the very top of the band, at 14.343, we have a SWR at 1.1. So very usable on the entire band. That's what makes this antenna very great. Now, if we wanted to change bands, all I would do was unplug part of the counterpoise and then just shorten the whip until we get a good SWR reading. So I'm going to go ahead and hook this up to a radio and kind of do some comparisons. I might set up a performer and just kind of compare the two. All right, so what I'm going to do now is I've got both antennas set up on a switch, and I'm just going to do a couple tests. I'll do some RBN tests, and then I might try to do some Kiwi SDR. I don't know how good the bands are, and I'm QRP right now. So I'm just going to send out a couple tests, see if I can get some RBN spots on each antenna so we can kind of compare. All right, so I got some RBN spots on both antennas, and I hit more with the Challenger than I did with the Performer, and I'll share those with you here. It looks like I hit 6 with the Challenger. The max was 25 dB and the average was 12.5. And then I hit 4 with the Performer. The max was 16 and the average was 8.75. So it looks like the Challenger, according to the RBN, did better. I wasn't really able to get really good results with the Kiwi SDR, at least QRP. A lot of them had a high noise level, and my signal was coming in fairly weak, or just above the noise level. In Lincoln, I was about an S5 with both antennas. In fact, the Performer was just slightly stronger. But you know, these antennas are different with a lower takeoff angle of Challenger. That may not really prove a whole lot. So I'm going to go ahead and switch to the Challenger. I'm going to start out with a little bit of a QRP activation, and then I'm probably going to retreat to the truck. It's very windy today, and it's kind of irritating. So I don't know how long I'll actually stay here at the picnic bench. But let me go ahead and find a frequency and get that set up. Now I might have to switch to my FT891. I like operating QRP when the bands are good. However, it's not much fun calling CQ and not making a whole lot of contacts. All right. I got Richard on 40 meters earlier today. Someone down in the noise, I didn't hear him. Oh, there's David. All right. All right, so we're making some good contacts. I got a park-to-park with David, K2JVB. I gave him a 329. He gave me a 329. But we made contact. Good signal reports in Idaho, California, and Ohio. So I'm probably just gonna activate a little longer QRP, see how that goes, then I'll probably switch to my rig in my truck just to get out of this wind a little bit. So I'll be back here in a little bit. All right, so I just finished up my activation with the Challenger. Overall, pretty good activation. A little bit slower this morning, however, the band seemed to improve quite a bit this afternoon. I got a lot of really good signal reports, especially west of me into California. In fact, a lot of people said I was quite loud in Washington, Oregon, and California. Most of my contacts were on 20 meters. I think I ended up getting like 130, 135 contacts on 20 meters, something like that. I got a few on 17 meters, I think 11 contacts, and then 15 meters I got, I think 6. Ended up having a nice little rag chew with my buddy W6EO on 15 meters. So that was kind of fun. Overall pretty good. It was fairly windy today, so I gave up on the picnic bench pretty quickly because it was just a little too irritating. It kind of put my Challenger PVC mount to the test. The antenna was bending quite a bit, so I need to check and make sure everything still looks good inside the mount, but overall a pretty fun day. If you haven't tried the Challenger, I recommend you build one and try it, and let me know what you think. 73.